Good afternoon or good morning to everybody, depending where you are. And welcome to the 2022 Scientific Seminar of GenRe-Mekong. We would have loved to do this in person, and unfortunately, things still aren't quite as good as we would have liked with travel, but we hope that the next time we're going to be able to have a live audience. Meanwhile, we thank you very much for attending this. And without further ado, I will introduce Professor Arjen Dondrop, who is the chair of the Regional Artemisinin Initiative Steering Committee, and works at the Mahidol and Oxford Research Unit. He will say a few words to open this meeting. Arjen?
Okay, thank you, Olivo, for this introduction, and an honor, of course, to say a very short few opening words for this investigators meeting of the GenRe-Mekong project. I think a few points I want to make. I think over the last years, during the lifetime of GenRe, we have seen, I think, sort of a paradigm shift that nowadays genetic surveillance, molecular surveillance really have become more and more part of routine malaria surveillance, especially here in the Greater Mekong Subregion. And I think that is great. And the other development going with that and GenRe helps with that a lot to develop national capacity to do the genetic surveillance. The second thing is that genetic surveillance, of course, the primary objective is to look at antimalarial drug resistance markers. But the project has also shown the much wider capabilities of genetic surveillance. And I see in the meeting these 2 days a few very interesting use cases will be shown. For instance, that it is a great tool for outbreak investigations and also to see how resistance travels through the different countries. And then lastly, maybe to say, you all know now that Artemisinin-resistance has also emerged independently in several African countries, so in Rwanda, in Uganda, in the Horn of Africa. I think it's very important that all the learnings we have from the last 10 years here in the GMS and where GenRe has contributed a lot, how those can be useful for the African situation when things are further evolving there. So with not much further ado, I hand back the microphone to Olivo, and I wish you all a very pleasant and good meeting these 2 days. Thank you very much.
Well, thank you very much, Arjen. That was a very clear message. We have covered a lot of ground the last few years. We have gained acceptance, and now we're going for new capabilities, and also there is going to be a lot of scope for transferring the experiences here to new territories, particularly in Africa, as you say. What I wanted to do now is to give those of you who are not familiar with the GenRe-Mekong project a rundown of our activities and our objectives. And so I will only spend 10 minutes or so doing this. Oh yes, okay. So the GenRe-Mekong project was conceived as a partnership project. In other words, putting together scientific capability from the Oxford University, from the Mahidol Oxford Research Unit, from the Sanger Center in the UK, and partner this technological capability with the public health people working in the different countries of the Mekong subregion. So the idea was basically that we would organize collections of samples from as many malaria cases as possible throughout the region, and the best way to do this would be to partner with the control programs in the various countries and operate through the public health facilities in the endemic region. Then the samples would then be processed first at centralized labs in the previous years, but now we're opening labs also in the endemic countries themselves, and basically obtain a range of genetic genotypes of results that tell us basically about the parasites, about whether they're resistant to drugs, about whether they're related to each other, about whether they're spreading, and so on. And this would then be communicated to the public health authorities, and then hopefully support the decision-making process. And as you can see on this map, which is now somewhat outdated, we have a lot of sampling sites from all the countries in the region, and the numbers of samples has been continuously rising, and we have collected around about 15,000 samples so far. That's of Plasmodium falciparum, and there's over 5,000 vivax samples as well that we've collected. And by the way, as you can see from this table, you know, in the earlier periods, we collected a lot of samples through large-scale research projects, but nowadays a lot of the samples come from the projects with the control programs, which are shown in yellow here. Okay, move forward. The way in which we've simplified the collection process was to make the collection of samples very straightforward, very easy to integrate with the control programs, and we provide all the materials, and we don't require a lot of data. We just want to know where and when the sample was collected. We try to support each country by providing not only the materials, but also the protocols, submitting the ethical approvals, supporting local coordinators that move the samples between the sites and the labs, by training the staff that participates. You can see some nice pictures there from our trainings in Vietnam and also in Cambodia. And ultimately, we also want to support the development of scientific talent in these countries that will work with us to better communicate the results to the control programs. I mentioned earlier on that we've created processing labs in 2 countries. Well, in Vietnam, the laboratory is operational now, and I got to thank Dr. Nguyen, who's actually on the line right now, and she manages the laboratory in Ho Chi Minh City, and we've been very successful at implementing this, and we completed all the testing periods, and we're now basically in the production stages. And Thailand is going to follow very shortly within this year, we believe, and the laboratory here will be managed by Professor Malika Imwong. What data do we return from these samples? Well, what we return is what we call genetic report cards. These are data sets that consist summary of the mutations that we know to be associated with drug resistance, which is the major problem with genetic epidemiology in the Greater Mekong Subregion. So we have markers for resistant to artemisinin, to piperacin, but also to historical drugs that have been used here in the past. The other thing that we do is we create these genetic barcodes, which are some form of a summary of the genome of the parasites, and these have actually been proved very useful in order to look at, for instance, analyzing outbreaks, analyzing the epidemiology of the parasites, and there will be more later on in some of our sessions later. Of course, if we just return genetic data in the raw form to the control program, it's not going to be very useful, because it actually does require a lot of literature search and a lot of additional knowledge to determine whether a parasite is sensitive or resistant to a particular drug. So we make those predictions in the data that we return to a control program. So we end up with a sort of relatively simple classification, which then enables us to show on a map how prevalent the resistance to a particular drug is. And as you can see from this map, which is from our publication that was released last year on eLife, once we put this data together, and especially if we put different countries together, the pictures that we get are very clear, and they are very informative about the spread of resistance. And the interesting thing is that the more samples we have, the more in-depth we can go into analyzing the data. So in this case here, we have a comparison between two different seasons in Vietnam, and you can see that here we're going down to district level within 3 different provinces of Vietnam, and we show from one season to the next the shift of drug-resistant samples eastwards and the change in frequency in the different districts. We also, especially in the last year, 18 months, we've also been looking at other epidemiological analysis. So, for example, you can see here a map of what we call connectedness, which shows how much we estimate that parasites travel between one district and the other of the provinces of southern Laos. And you can see here very clearly that there are 2 regions with relatively little exchange between them. And actually, when we look at the characteristics of the parasites, what we do find is that we could actually justify this by monitoring 2 main strains that are actually circulating in these different regions. So you can see that we are able to look at strains, identify them, and assign different parasites to a particular strain, and eventually also look at where these strains come from. So here, what we've shown, for example, and my colleagues here at MORU will go through this later on. We have shown, for example, that in southern Laos there has been a sort of battle between different Artemisinin-resistant strains, and the one that was prevalent until 2019, C580Y, has now been overtaken by another one which carries the R539 mutation. So that's the science, and we're going to present some of these results. But with the little time that's left here, I would like to also talk about how we would like not only to do the interesting science, but also enable our collaborators from doing it with us. So in this second phase of GenRe-Mekong, we have extended the surveillance network to include more partners, but also we have planned many activities, of which this forum is one, but that will include training activities, which will start later on this year, and software tools that can be used by the scientific partners in the countries. And essentially, we want to build capacity. We want to transfer the knowledge, the methods, and the capabilities to scientific experts in Vietnam, Laos, Cambodia, Thailand, and Myanmar, hopefully, and work with them in order to analyze the data, to share it across the borders, but especially to inform appropriately the control programs and other public health authorities. And that is all that I would like to do in my introduction so far. I would like to thank very much all the collaborators here, and I purposely haven't put any names in here. I'll just go by organization. Literally, we're talking of hundreds of people that have contributed to this project in the last 5 years or so. But especially, I would like to thank all the public health partners, the National Malaria Control Programs, and over here you can see, you can find your own symbols, and also the units that have supported us with scientific expertise, like MORU in Laos, OCRU in Vietnam, Mahidol here in Thailand, SMIU, and others. And finally, of course, a word of thanks to our funders, in particular the Bill and Melinda Gates Foundation and the Wellcome Trust, and as from this year, the Global Fund, who's been funding the capacity building activities. And with this, thank you very much. And I would like to hand over to Arjen for the rest of the meeting.
Okay, thank you very much, Professor Oliver, for the providing an overview of GenRe-Mekong project. And my name is Arjen. I am scientific coordinator for this project, and I will give you an overview of the conference. So we will go through the two-day conference with today and tomorrow. So for the conference, there are 4 sessions. Today, we will start from the session 1, from sample to laboratory to data analysis, that will share experience from Vietnam. And the second section will be about the multidrug-resistant malaria in Cambodia and its expansion in the Greater Mekong Subregion. So this time we'll sharing the experience from NMCP from Cambodia, and also will join from the Wellcome Center Institute for the technical support. And for the second day, we will go through using the genetic surveillance data to support malaria control and elimination. So for the session 3, tomorrow we will see the thing that we have performed and we are going to do in Laos, with the investigation into outbreaks of emerging multidrug-resistant malaria in Laos. And the last session, you will see the perspective on genetic surveillance of Plasmodium falciparum and Plasmodium vivax. On tomorrow's session, we will have a speaker from the University of Ghana, and also the presentation from the Menzies Institute. Okay, thank you. So now we will start for the first session, and we will have about 5-minute transition time. And I will give the floor back to the Professor Oliver for the moderate for the first session. So the first section there are 3 speakers that will talk about sample to laboratory to data analysis. You can hear the experience from Vietnam. Okay, Professor Oliver, please.
Thank you. Just as a way of introducing the topic, of course, we're all familiar with the difficulties that we've all gone through during the pandemic period, and it's been a very interesting time for malaria, I would say, and actually a lot has gone on in different ways in the different countries. So that's been very interesting to me during this period. So we will start from Vietnam, where there have been several developments. One has to do with the reduction in the number of cases, but also we have made a very great progress in starting up laboratory capabilities there. So we will talk about these two aspects of the project. And first of all, I would like to welcome Dr. Quang from the Kinyon IMPE control program. So this is the Central Vietnam Institute of the National Malaria Control Program. And Dr. Quang has been has been our great collaborator in Vietnam for several years now. And he will give us a rundown on the malaria epidemiology and the current situation on drug resistance in Vietnam. Dr. Quang?
Yes. Yeah, thank you, Professor Olivo, and thank you very much for your Dr. Ariza. Hello, everyone. I'm very happy to be here, and thank you for your organization invite me for the an important webinar, very important, present and future of the genetic surveillance of malaria parasite in the GMS. Today, I would like to talk some more about the update on the malaria epidemiology in the year 2020 and 2021, and anti-malaria drug resistant in Vietnam status year by year. Next slide. Firstly, I would like to talk about the as you know already, similar to all the country in the GMS, malaria trend in Vietnam from the year 2016 until now, roughly, sharply. And especially on the right side, you can see Vietnam malaria before last year and last year reduced sharply, and proportion per 1,000 population also reduced very clear, and you can see some belonging to the manufacturer. I will talk here to you later. And this the malaria trend in Vietnam very impressive decrease in case only 2 years, not 2 years. Next please. And about the Vietnam malaria in the recent 5 years, you can see the total test case decreased 25%, total case decreased 74%, and the total blood falciparum and blood falciparum mixed decreased 82%, and especially in the vivac decreased 60%. And especially in the past 2 years, they know the malaria death, and they know the outbreak of the malaria. Next slide. About the progress toward the blood falciparum and blood vivac elimination roadmap, you can see in on the left side, you can see the blood falciparum and the mixed infection decrease about the 22%, and in parallel, blood vivac case also reduced more than 62%. And on the right side, you can see the malaria parasite formula about the falciparum occupy more than nearly 60%, and the blood vivac more than 40%, and other parasite a little under less than 5%. And in the year to 2021, it seems to be the popular parasite formula is similar to before last year. Blood falciparum about 44% and the platinum vivac in 55%. This is the remarkable change because some province in Highland and some province in the northern part of Vietnam have some not outbreak, but somewhere have a change to the between falciparum and vivac, and some communal health station detect the small outbreak of the vivac in last year. Next slide. And about the malaria control and elimination roadmap, we have a target and challenge. Looks similar to the other country in the GMS. You can see by the year 20 for reaching the zero malaria target by a long and active roadmap. But until now, the total 36 per 63 province and city at the certified malaria free and elimination. And we also would like to maintain sustainable factor for the province. And about the falciparum malaria elimination, we would like to eliminate by the year 2025, and all species of the human malaria elimination by the year to 2030. And now Vietnam is on the right track, both blood falciparum mixed infection and especially in the platinum vivac radical Q maintain the sustainable factor for elimination of the malaria in some province. And about the obstacle and the challenge in malaria status in Vietnam, we are facing such as drug-resistant, insecticidal resistant residual platinum vivac parasite in high proportion, create many platinum vivac reservoir, and the last were very difficult to uncontrol the forest goer population, reducing government funding in the recent 3 years. Next slide. About the antimalarial resistant status of the falciparum and platinum vivac in Vietnam, we would like to talk with you. Next slide, please. On the right side, you can see the map of Vietnam, and somewhere we create and we establish the sentinel site from Quang Binh to Bình Phước. On the left side, you can see the some province, for example, Gia Lai, Đắk Lắk, Đắk Nông, and Bình Phước have borderline with the Cambodia. And on the right side, you can see the Quảng Trị, Quảng Nam, Khánh Hòa, and Ninh Thuận. Here they have borderline with Lao PDR and some of the coastal province. Especially, I would like to talk with you especially in the year to 2019 in Gia Lai and in Đắk Lắk, with a total case more than 50K. But we have a late treatment failure more than 34% and more than 67%. And also we have a day triple positive more than 30% in Gia Lai and in Đắk Lắk. And until now, efficacy of Artemisinin-resistant in treatment for uncomplicated falciparum malaria. As you know already, Artemisinin-resistant here is the drug of choice for falciparum since the year 2003. But from the year 2003 until the 2017 have high efficacy and high ICBR. But from the year 2020 at the inlay of this year of 2017 until 2020, overall corrected PCR late treatment failure rate are from the 27%, 56%, 43, 34%, and 68% in Đắk Nông, Bình Phước, Gia Lai, and Đắk Lắk province respectively, where the border Cambodia. Next slide. And here under the series of the Artemisinin-resistant, not only for Artemisinin-resistant, but also for resistant at the partner rock. We have some clinical trial at the urgent trial of the medicine with the Baramat. New Baramat have a high efficacy in the treatment for falciparum, but we have mentioned about the high positive DAY3 at the partial resistant for artemisinin and its derivative. In the table, you can see in the Đắk Nông, Gia Lai, Khánh Hòa, and Ninh Thuận, with the total ACBR on the day 28 and ACBR on the day 42, you can see only in Đắk Nông have a efficacy about the 84.2%, and another the rest of the province, Gia Lai, Khánh Hòa, and Ninh Thuận, you can see the efficacy nearly 100%. Next slide. And about the efficacy of artesunate pyridine or pyramid of blood vivat and falciparum. The last 2 years, we have a collaboration with the ADF-BD in Australia. Here, the first trial of the pyramid in the treatment for blood vivat in Vietnam. With the full data ongoing for ASTMS presentation in this year. But preliminary results show that the pyramid had the high efficacy in the treatment for adult and the children blood vivat patient. Here the first trial and only trial in Vietnam. We use the ACT pyramid for the blood vivat in Vietnam. Next slide. In the second ACT, we would like to see at the second option, and in case of the serious Artemisinin-resistant spread out and serious, we use the artesunate and mefloquine. We do the clinical trial in Đắk Nông, Đắk Lắk, Gia Lai, and you can see the artesunate and mefloquine with the total the sample size 156 people, and with we have a cure rate about 100% for all the sentinel site. However, DAY3 positive is still high, more than 20% at the 4 sentinel site. We think the artesunate mefloquine here have a highest efficacy of in the treatment for blood falciparum, but we would like to save the artesunate mefloquine at the last weapon for the last mile malaria in the near future. Next slide. And about the efficacy of the chloroquine or chloroquine plus primaquine in the treatment for blood vivat, we would like to review on the sentinel side from the in the northern part to the southern part and in the central highland of Vietnam. Here for example in Bình Thuận, Quảng Nam, Quảng Trị, Ninh Thuận, Gia Lai, and Đắk Nông province, and with the periods from the year 2000 until the year 2019, you can see the cure rate more than 89%. Somewhere have a recurrent more than 10%, but at that time and until now we haven't know the any molecular marker for differentiate the reinfection or relapse. We don't know exactly. However, we saw that about the recurrent proportion less than 5%, and therefore we don't worry about the efficacy of the chloroquine in the treatment for blood vivat. Next slide. And about the molecular marker, we also compare K13 molecular marker in GMS from the year 2015 to the year 2020. And you can see we compare together with the Cambodia and Myanmar and somewhere in Vietnam, especially about the marker C5A0Y have a so high in everywhere we conduct in the clinical trial in vivo test. It seems to be the more than 38%. And we think the resistant progress in E very complex and highest frequency of the marker C5A0Y. Myanmar and Artemisinin TS in the central province border with Cambodia have a high rate of the C5A0Y. And until now, no evidence-based medicine, especially for the resistant marker to mefloquine inside. Next slide. About the genetic surveillance of the malaria from the year to 2017 until now, I think that this slide, Dr. Nhiên will talk more detail in the next presentation, and Professor Oliver Mioto also introduced ready. This study mostly with the objective to determine of the prevalent and geographical distribution of resistant linked genetic mutation in clinical blood falciparum and vivac isolate for prediction of the drug resistant everywhere in case of the sample size very small for the TS and EDDS in the central and highland of Vietnam. And until now, about the malaria case in Vietnam, focus in the central and highland of Vietnam, and in the northern part and the southern part very rare. And therefore, in the next time, we will focus about the genetic surveillance of malaria in this area. Next slide. By the way, by the project, owing to the GenRe project, we have some result. Firstly, I would like to talk about the warming of drug resistance in Đắk Lắk province. You can see in the red dot with the extremely high level of Artemisinin-resistance in Đắk Lắk, and about the and another TS conduct in this province, so that the Artemisinin-resistant treatment late treatment failure so high, more than nearly 70%. Next slide. And about the dynamic of drug resistant spread in the Gia Lai province. Gia Lai very near with the Đắk Lắk, and somewhere when we conduct the TS here, we saw the treatment failure also so high, more than 40%, and a lot of the K13 propeller mutation with the red dot. You can see the outbreak underpin. Not only for K13 but also blood mapsing genetic marker. Next slide. Especially in Vietnam, until now, some result from the Professor Oliver Mioto and from Dr. Nhiên, so that the malaria parasite, especially blood falciparum, is still sensitivity with the mefloquine, and therefore we think the artemisinin mefloquine is the last weapon. Next slide. About the molecular marker in antimalarial drug resistant, you can see I would like to review about the curve with the red color in the red color dot with the Cambodia border. You can see the some province in Vietnam, for example, Gia Lai, Đắk Lắk, Đắk Nông, and Bình Phước, so that the with high proportion of the K13 propeller and blood mapsing also. Most of molecular occur in province border Cambodia, and at the present they know the mefloquine resistant evidence, especially via molecular marker. Next slide. Next slide, please. And about the potential and hidden marker in blood falciparum and blood vivac. Now we ready know and we already detect many molecular marker and copy number variation for component antimalarial resistant ready. However, we haven't know. It seems to be we haven't know the marker for pharmacine resistant, marker for barcoding resistant, and marker for virus. And here the very difficult to determine and very difficult to determine about the reinfection or recurrent. Very difficult. Next slide. About looking forward to the future study, until now, in spite of the COVID-19 pandemic, not stop. But some malaria foci in the central highland of Vietnam still occur. Many plasmodiaphyte foci are emerging in the central and one province in the northern part with the proportion of virus more than plasmodiaphyte from. We use the integrated TS and IDS activity in the malaria endemic zone needed with the new medicine, paramat and artemisinin beflocking. Also, we would like to foster of the malaria surveillance and monitoring activity in line with the efficacy way. We would like to change in the context of the malaria case reduced sharply. We suggest we change of the research collaboration in molecular aspect. Firstly, policy maker need to understand genetic marker surveillance at resistant early warning system. It's been very important and early warning sign. The second, pilot detection of the plasmodiaphyte hypnozoid formed by molecular tool. Yes or no? We would like to we want to detect hypnozoid form in the patient during 2 years from the radical Q for them. Thirdly, we track detecting propeller mutation, plasmapsin 2 and 3, exo E415G and other molecular marker for the plasmodiaphyte is very important in the near future. Wide open for molecular marker in the new hotspot of the malaria and how to apply at the routine monitoring by the National Malaria Control Programme is also very important. Next slide. Once again, we would like to say thank you for your research collaboration in the past 5 years, and we look forward to collaborating with you, all of you, in the next in the malaria elimination roadmap. Thank you very much.
Thank you so much, Dr. Quang. That was extremely clear and extremely comprehensive. And I thought what was particularly interesting is we can see a sort of clear process of introduction of the new therapies, which has been sort of very carefully managed. We got a couple of questions in the Q&A here. Arya, do we take everything at the end of the sessions, or
yes.
Should we take some now?
I think we will wrap up for the question in the panel discussion part after speakers.
So we will hold the questions for the time being, and we will move on onto the next speaker right now, who is Dr. Nguyen from the Oxford University Clinical Research Unit in Ho Chi Minh City. As I mentioned earlier on, Dr. Nguyen is our precious collaborator in Ho Chi Minh City. She leads the molecular malaria lab at OCRU, and she has spearheaded the implementation of GenRe-Mekong laboratory analysis within a country. So just to give you a little background on this, until this year, really, our samples have all been processed at the Wellcome Sanger Institute in Kingston in the UK. Now, this is primarily because the process is technically quite challenging and requires quite a lot of sort of advanced equipment and so on. And the protocol is far from simple. And Dr. Nguyen has worked with the Wellcome Sanger Institute in order to transfer this protocol to an endemic country. This is the sort of first successful implementation, and it is being used as a template for implementing in different countries, not only in the GMS, but also in Africa, in countries like Ghana, the Gambia, and so on. So with that, I would like Dr. Nguyen to tell us about her experiences in doing so. Thank you very much.
Hello everyone, my name is Nguyen. I'm from Oxford University Clinical Research Unit based in Vietnam, and many thanks Oliver for the introduction. And many thanks for the organizer for inviting me for this topic on this important scientific forum about genetic surveillance and one of the top trends in research recently. And my talk today is about building and implementing in-country laboratory for support genetic surveillance of malaria in Vietnam. And before coming to the main part of the talk, I would like to introduce you. As you see in the picture, it is the Hospital for Tropical Disease in Ho Chi Minh City. And this hospital is specific for tropical disease in Ho Chi Minh City with more than 500 beds and maybe one of the biggest hospital for tropical disease in the world. And why I introduced this hospital? Because our Oxford University Clinical Research Unit is here 30 years old, and we are part of the hospital, and we are located in the laboratory department building with more than 300 staff working in many infectious diseases, including malaria, dengue, TB, CNS infection, enteric, emerging infectious virus, zoonosis. And our aim is to have positive impact on global health, especially in prevention, diagnosis, and treatment of disease in partnership with the Hospital for Tropical Disease, with local hospital, local research institution. And our main collaborators for malaria research in Vietnam is MP Quang. And you see in the next slide, they are laboratory and specific for molecular research diagnostic. And we have been working for many types of infectious pathogens. Our team are very experienced in whole genome sequencing of bacteria, viruses, and working with the GenRe-Mekong project, we have an opportunity to do the next generation sequencing with malaria parasites. And some of the key equipment have been funded by the GenRe-Mekong project to make our work more efficient. So it is the introduction to let you know more about our laboratory, and it leads to why our team is considered to be one of the team to implement the procedure locally. And as you have heard in Dr. Quang's previous talk, that dealing with antimalarial drug resistance is one of the big challenges of Vietnam and neighboring countries. And there were the big changes in the way Vietnam monitoring the drug resistance in 2017 with conduction of the genetic surveillance in malaria provinces. And the big change is we conduct sentinel sign monitoring combined with the clinical trial, the TPS, and now change to large-scale surveillance. And from using individual markers to high-throughput genotyping In collaboration with the National Malaria Control Programme, especially in PPM, we conduct the surveillance in 12 malaria provinces, mostly located in central and highland of Vietnam. And the number of sites increasing by year. We start in 2017 with 30 sites, and currently it's nearly 90 sites in the region. And like Professor Oliver has introduced in the first introduction, the procedure, the sample collection is done simply and coordinated by the National Malaria Control Programs. The sample was collected from the health center and hospital. Then it was transferred to output and center for genotype analyze and generate the report. The report was then communicated with the National Malaria Control Program, hopefully to support the control and the elimination policy. But to dealing with the drug resistance, it is important to have the data timely and comprehensive. That's why it comes to the decision to conduct the in-country sequencing to support the surveillance. And in general, over the 5 years, we have collected sample in 12 provinces, and it is the overall status of the sample collection, as well as the proportion between the species, Panspermia and Dieback. And those data also was report to the National Malaria Control Program together with the genotyping and the drug-resistant genotype. So far, more than 4,000 samples was collected in Vietnam over the last 5 years and arrived our lab in Ho Chi Minh City. Back to the decision to perform in-country sequencing supported surveillance. We have preparing for the 3 stages. First is training, then we test the procedure and comes to the operational procedure. We plan preparing and start the training in March 2020. And it takes a lot of effort of single team and our team here to check, to prepare equipment, consumable, reagent, primers, and review the SOP as well as the staff eligible for the training. And you may find the key information of the procedure published in the study resource of this genetic surveillance in GMS and South Asia to support malaria control and elimination, published last year by Chris and Oliver. In the study resource, many detailed information related to the procedure has been published. This is one of some of the pictures of the training. It is very strange that because during that March of 2020, it was a warning everywhere about the COVID pandemic in the UK and as well in the Asia and other countries. That's why we have to conduct the training straight away. All of the technical was communicate online with Dr. Shavante and Mozam support. Then the lab work has been done by the local team. And on training later by Oliver and Chris was done online. After that, we have the offline discussion with Shavante and Mozam to prepare to test the procedure in update. And one of the key highlights of the procedures, we prefer to have a high throughput, lower costing and comprehensive genotype using the Illumina methods. And the currently product target about more than 140 loci in the parasite genome, and we can process in one run 4 plates of sample equivalent to 384 samples. And the sequence was done simultaneously. Back to the procedure, testing the procedure in Vietnam. We start the testing procedure after the training, and we completed in July 2021. It means it takes us more than 1 year to complete it. There's many works in the testing procedure, including testing equipment, testing with one plate of sample, calculation and balance the primer, update the SOP, QC, and discussion for troubleshooting with within the team and also with the supporting from the team. And finally, after several runs, we have the good result, and it is also was independent verification by MORU and the team, especially on species detection and the genetic barcode. And when the procedure has done, we moved to the operational procedure from October 2021, we scale up to 384 samples per run with update SOP, more improvement on QC, advised by the team, and also we identify and we resolve some issue of equipment contamination and have discussion with the team and also Oliver team from MORU. And after that, we are confidentially to perform the procedure in Vietnam. And previously, before we implement the sequencing procedure in Vietnam, we just received the sample registration and processing for the copy number variation in April. After that, all of the sample was sent to genotype. And now, after we got trained and can run the procedure locally, the sample processing is also done in country app. And in coming soon, the cloud-based tool to help to analyze the data and also mapping to have a report and to help us to timely and quickly generate the data to report the National Malaria Control Programme. And to say about the implement the procedure in Vietnam. First, to make you more understand about the procedure. So far, we received samples from many sites in Vietnam, from Laos and Cambodia. All the samples were sent to Ho Chi Minh City, and these are the samples we received so far. And all the samples arrived approved, carefully packed. We check the barcode comparing between the document and the sample. The sample also has been done QC check and registered into a system called ROMA, sample management. And the PI from other study and country can track their sample from that sample management website. And it is a very complicated procedure. Before sequencing, you have to prepare the sample with DNA extraction, selective whole-genome amplification, and then move to library preparation by several steps like amplification, tagging and adapter, purification, quantification, polling, and come to mass sequencing. The raw data now has been uploaded, and with support from the team was perform the genotyping and data translation. And from the releasing data, you can see, like Dr. Oliver said previously, there's the genotype related to drug resistance. And from the genotype, we can integrate and prediction to the drug resistance related to artemisinin, piperacin, chloroquine, butymetamine, and sulfadoxine, and as well networking. Also, the 101 SNP barcode generated from the genotyping can help to track the parasite population. the data also show the multiple infection of the sample and as well as the species of the parasite. Some of the results has been presented by Professor Oliver and Dr. Quang previously, but I would like to highlight at this stage. Once we have the data, it moves to mapping and reporting to the National Malaria Control Programme. And I want to highlight some use cases of the genetic surveillance. Once we have the data, we can understand the frequency of drug resistance that relates to the prediction of drug resistance in the region. As you observe in the example of what we have seen in 2 malaria seasons in Yala, that the genetic surveillance have to identify the hotspot as well as the dynamic of the resistance spread. Also, with some new drug is considering to use, like Dr. Quang said, in his artemisinin-resistance can be considered as the last beacon. We can have to monitor the resistance to new drugs to see that the possibility of using this drug in the future. One of the other case is the genetic surveillance have us to have the warning of drug resistance in that in 2017 that lead to the TES misconduct in that province later. I thought that you remember in previous slide of Dr. Quang about the result of TES in many malaria endemic provinces that all the result has been done until 2016, and since 2017 with the warning message from the genetic surveillance result from Dakhla, and the National Malaria Control Programme decided to continue the TES in Dakhla and other related provinces. And you has observed in previous result of Dr. Quang about the result in 2019. And like the experience from Dakhla, we continue to monitor the resistance to the current treatment in new locations where treatment has not been changed. As you may know that Malaria Control Programme in Vietnam has decided to change to Paramax in several provinces with high prevalence of drug resistance. And there are some provinces has still use DP for malaria treatment, and we continue to monitor the drug resistance with the DP in those provinces. And you may see in this result, we also highlight the high DP resistance in some provinces near the coast like Phú Yên and Bintan in 2020. In summary, I would like to summarize some achievement we have got when implementing the procedure. However, I would like to say it with the challenges we face in each of the topics. First of all, genetic surveillance has been a useful tool to monitor the drug resistance, as you see in several use cases I just presented. However, the use cases is vary between country and region because it depends on the level of drug resistance in each area, in each provinces, and also state of malaria elimination within the country. And also the implementing of in-country laboratory with timely and comprehensive support evidence for strategic decision making in malaria control and elimination activity for participants. However, it is a complicated genotype procedure, and it may require some minor optimization to adapt to local capacity. Also, it requires the supporting for troubleshooting for the team who have never done it before. And we also need the communication to share experience between local laboratories when implement the procedure. And additional markers, new drugs may be used for Panciparum like combination with lumefantrine and amodiaquine may be added to the panel once the marker covers representative. Another point Currently, the data analysis and pipeline currently supporting by single team, and we expect the timeline for the cloud-based tool readiness and update pipeline to release the result faster than that. And also because the data was primarily used to report and communicate to the National Malaria Control Program to support the decision making. So in Vietnam, it was a direct communication between our two NPPN and National Malaria Control Program. And in Laos and Cambodia, it is communicated to GenRe team in Malaria. So I think we need some more comments from the people of the National Malaria Control Program for improvement. And finally, one of the big challenges also, we would like to support the understanding of P-virus epidemiology, drug-resistant, and elimination. And finally, I would like to thank for the sponsor and the collaborators, and most important, the National Malaria Control Programs of Vietnam and Laos and Cambodia also help to support us to implement the procedure in country, and especially the people. I will just highlight some of the people, but would like to thank many people for supporting us for the activity. Thank you very much.
Thank you very much, Dr. Nguyen. That was a great overview of the many challenges that were faced in the creation of the GenRe-Mekong laboratory in country, which, on top of being a challenging activity in itself, was done in the middle of the pandemic, therefore without the ability of doing of the sort of training teams coming into the laboratory and all this type of stuff. So okay, I got a few questions that have been put on the Q&A window here. So there's a question here from Tim Pollington. Says, thank you, Dr. Quang. Do you think the decline in incidence, what do you think caused the decline of incidence in Vietnam since 2020? COVID curfews causing less vector exposure or disrupting malaria reporting? How has the proxy of PFBV RDT positivity rate changed during this time? So would you like to take that question, Dr. Quang?
Yeah, thank you very much, Dr. Tim Pollington, on your interesting question about the cause of the decline incidence of the malaria case in Vietnam since 2020. As you know, in the COVID-19 start from in the first year of the 2020. And therefore, many migrant and mobile population from the central highland of Vietnam moved to from central highland of Vietnam moved to the southern province for the packing of the seafood and working together at the furniture worker. And as you know, ethnic community with the with the low income. When they move to the southern part, they have a high income and high salary and very stable in the long time, and therefore until now they stay there in the long time, and therefore we renew of the mobile and migrant population go to at the forest go to the deep forest. And here the first reason, and the second reason, maybe you know, the COVID-19 caused the social distancing and the lockdown somewhere at the mid 2020 and first quarter and second quarter of last year, and therefore the Vietnam government not permission for population move to everywhere, only in the local, and limited movement everywhere. And here the second thing, and the third and fourth and so on. I think about the global climate change with the mosquito population reduced by the survey in the short time, and about in Vietnam, you know, the reason why maybe the rapid diagnostic test affecting on the formula of the parasite. I don't think so, because until now Vietnam are currently using the RDT SD bioline from SD bioline PF and BV, LDH and heterogeneous protein 2, and therefore very easy to differentiate the blood falciparum and blood-borne virus. In parallel, we also collect the slide from the patient, and we do the in parallel, and therefore the result, I think, the credible and reliable.
To follow on what you just said, there is another question here from Tess asking why the P. vivax foci are arising more than falciparum.
Thank you for your question from the Dr. Ted Vesuren. The reason why the blood-borne vivax are arising and emerging in some way in Vietnam in recent years, as you know already, for falciparum very easy, only the ACT and following one single dose for primary phosphate, only 1 day. But for vivax or the mixed infection between falciparum and vivax, we need to use the consecutive 14 days for primary. But we are facing about the poor adherence and poor compliance from the patient. When they use the primary, after 3 days, after first 3 days for chloroquine and primary, it's okay. Stop fever and stop fatigue, and they feel that better. And after that, we provide for them about the rest of the 11 of the primary days. But they don't use the primary in the full dose, and therefore it is easy to call the relapse onward. It is the reason why. It is the main reason why. And therefore, some blood-borne vivax foci are arising somewhere high prevalence of the blood-borne vivax in the central highland of Vietnam. Yeah.
So, and quickly, I would like to go on to the third question here, which actually I had a very similar question. So you seem to be implying that there is some initial sign of it says here late treatment failure, perhaps, you know, sort of less efficacy of the Pyramax in Dak Nong, and the question, I guess the question here is, do we suspect that there is actually some element of resistance to pyrrolizine, or is this simply the effect of artemisinin-resistance?
Yes, thank you. Hi, Dr. Richard Pearson. Once again, thank you for your question. The question have two components. The first component I would like to talk with you. I don't think so about here is the late treatment failure for Paramat in Dak Nong province, because in Dak Nong province from the year 2017 until the year 2020, we conduct two TS study. one TS with only the small sample size, only the 19 patient, and therefore we have a treatment failure due to the withdraw or the lot follow-up, and therefore we have a high treatment failure. But in the next in the second trial, we have a 43 patients on the Đắk Minh district of the Đắk Nông province. We have a 33 patients, and all of them have a high efficacy, more than 97%, and therefore we don't understand. We don't think here that initially treatment failure. And the second whole component in your question have a paramat-resistant marker, and until now maybe you can ask the Professor Olivo for more detail, because I know in Vietnam we use the paramat for 3 years, and until now is the 4 years, but until now only the day positive so high, more than 20%, due to basal resistant to Artemisinin-resistant, but about the baronadine resistant, we don't exactly, and we haven't know the marker for this. Yes, please ask the Professor Olivo. Thank you for your own question.
Yeah, well, thank you very much for that. I think, well, we'll have to take that offline, but I think we should probably discuss also with Dr. Nguyen and other partners what would be a good strategy to try to separate things and determine whether there really is a difference in the phenotypes with peronaridine. I think it's a very, very relevant question. In the 15 minutes or so that we have before the break, I would like to have a brief discussion with, well, primarily to hear what the control program representatives have to say about moving forward in the GMS countries. What sort of use cases will we need to address in order to help you sort of move towards elimination in 2025, 2030? So what public health are the most important activities are the most important to you? How can genetic surveillance support them? And do we need to change some things about how we do genetic surveillance? And actually, Dr. Quang, I think you've put in some very useful bullet points in your presentation, and thank you, and I will give those some consideration. I wanted to sort of tell you a few use cases that over time we've been thinking about, and I would like you to sort of tell me how important are these as we approach elimination. So I got 5 here described. One is how to characterize outbreaks. For instance, if there is an outbreak, what do we want to know about it? Do we want to know whether it's caused by a particular strain? Do we want to know whether it's just caused by increased transmission, and so on? The second one is to classify imported strains. So as you approach elimination, you have some cases that you detect. How important is it to know whether they come from over the border or not, and how can we address that? The third use case is basically to identify resistant strains and to track them, and to track the progress. And related to that, there is the fourth one, which is how to describe how parasites move and how they spread across the territory. And finally, there is another use case, which is how to evaluate the interventions that the control programs put in action. So what is important to us? And then at the bottom, I put in 2 other activities, both of which have been touched already by Dr. Quang. One is how to how to determine the phenotypes of parasites. We just discussed that, but also he mentioned vivax and how to distinguish between recrudescent reinfection and relapse. So that's another question. So Quang, would you like to give me your first impression about what is really important here in the next few years? We don't seem to have audio. Maybe Dr. Siv, you raised your hand. Please, would you like to weigh in on that?
Okay, thank you, Dr. Oliver. You hear me?
Yes.
Okay, thank you for the previous speaker and also Dr. Oliver. I'm also interested with the slide that Dr. Oliver has been present and also some from Oku University. The one that's currently the national program want to be improved is the how to strengthen the capacity of national program to map the genetic marker into our marine information system. Currently, if Dr. Oliver, you share some data from the result to us. Because of there is another analysis still going on. There is we need more data in terms of the Artemisinin-resistance and whether the different type and so on. We also need some marker of mefloquine. You already give to us, but if there is some marker of piperacin also good for us. We're going to map into our current malaria information system and translate into a map to share with our partner in the country to see the situation of the drug resistant or emerging something in our context. And one more point, I want to see the movement of the trend has been walked from one place to the other, and also expected to see the link to the population movement, whether there is a case that's resistant can be emerged in somewhere due to the population movement. So the two things that's in the country right now, in our marine inform system, we try to integrate the entomology the data. We also integrate the IDS data into the system, and hopefully we should have integrate all the resistance marker from our study here and to map into there. But we also glad to hear that there is capacity building may be provided from our collaboration, and also whether you think that different software may be nearly available or better than use the current system, or whether we are use the current system or each country by just provide some training and how to view and how to track the resistance by solving map in the country. Thank you.
If I could very quickly respond to that. Thank you very much, Dr. Siv. These are very, very important feedbacks. I mean, in the case of Cambodia, unfortunately, because of the pandemic, the processing of the samples has been delayed, so you've only got partial data so far. But we will bridge that gap. I think you know, your concerns have been heard. I think the point about capacity building is great, and we're going to talk a bit more about it later on. We are currently, as we speak, we are preparing training programs which we will put in place in the second half of this year. And we will offer these to any technical staff that of CNM and any other organization that supports you, that you would like to be trained. We'd be very happy to share the knowledge and also empower them with some software tools. And the idea is that yourself and the people who work with you and our other partners will actually be able to just take the data and in a rather simple way sort of slice it up and analyze it in a way that's useful to you. So that's moving forward. That is going to be a main activity that we're going to do together. Okay, Dr. Quang, would you like to comment on these use cases?
Hello, everyone. Thank you for your question and comment from Professor Olivo about the use case for malaria control and elimination roadmap in Vietnam. I think one of the UK in genomic marker and genomic data, I think that we can apply for them for identifying track resistant trend. And because in elimination roadmap, the malaria case confirm reduce step by step, and therefore we can clarify and classify imported strain. And the last one, we think that it is very important for us to evaluate of the intervention, for example, for the efficacy of the antimalarial drug resistant and efficacy of the antimalarial drug medicine. And in the research aspect, we think that if we use the genomic data from the GenRe-Mekong, it is easy to distinguish for recrudescent, reinfection, and relapse, especially for the blood-borne virus infection. For what? Because until now in Vietnam, chloroquine is also still sensitivity to the blood-borne virus, but somewhere have year by year, always somewhere emerge again. Although we are well controlled and we treat for them chloroquine and primaquine 14 days enough though. Yeah. Thank you.
That's okay. That's great. By the way, we will cover some more about Vivax tomorrow. We have a presentation from Dr. Sarah Auburn on a collaboration that we are moving forward in order to get more informative results for Vivax. So there will be more tomorrow. I wanted to ask, we have Dr. Keo from the Lao Control Program online. Dr. Keo, it'd be great if you could give us your perspective on the use cases.
Hello.
Hello.
Yes. Can you repeat your question again?
Yes. So I've put up here some sort of use cases that we think will be useful over the next few years until elimination. What is your sense of which ones are more important for Lao?
Yes. In my country, we have the strategy to eliminate 2023 eliminate PF and 25 eliminate PV. Now we just start conduct activity eliminate PF and WHO support the proposal sub Mekong region, we send the proposal to implementation, and now we implementation for PF, and then this is like a enhancement strategy, but for the own strategy we have the like a standard activity the same, like we implementing the both way, we do together. Yes, and then we concerned in the southern part of Laos, because a lot of cases in southern part of Laos, like that you see in the data from WHO or anywhere, and we concern for drug-resistant and concern the K13 mutation, the spread to anywhere, and then now we use the own drug, because the own drug like a high efficacy, we not change, but we concern about the buyback also, because buyback like treatment so long day, and actually we don't know compliant or not, because almost the case occur in the remote area, we cannot follow up, we cannot access like this, and this is we concern, but we try to eliminate in the 2020, 23 and 25. We how to say, and not only Laos, another country, sub-Mekong region, we do together. This is we concern like this, and now in my country, like this re-certification in this year, and then we should make the plan more, because right now we just implementation like the own certification, and then this is the challenge for us, everything. Yes. Okay. Yes, over.
Dr. Olivo, you unmute.
Yes, thank you very much, Dr. Keo. There's I would like to ask one more question to all of you. My understanding is that in order for the country to be declared as having eliminated malaria, then you actually will need to demonstrate that the cases that you detect within your country are not local transmission. So, you know, one thing that I've been thinking about is that in the last few years, especially with the C580Y strains and other resistant strains, there has been a lot of flow of these parasites over the border, such that it's very difficult really to distinguish one from the other. How do you plan to demonstrate that parasites have been imported instead of being local transmission? Dr. Siv, do you have a viewpoint on that?
Thank you, Dr. Olivo, for the question. For me, the current situation in Cambodia, the malaria transmission mostly occur in the country. We don't have concrete evidence that the case has been imported from other neighbor country. But last year we also concerned that in the Lao border with the Cambodia, because the Artiper province of Laos, they have some outbreak of P. falciparum, and I understand the cause of the increasing case because of the failure of DHA-PPQ has been occur in that area, especially the high Artemisinin-resistance, they are in the area. So a lot of treatment further, and the case has been increased. And during that time, we also the thinking that whether there is a worry that whether some case has been imported to our country, and so we have do the cross-border screen at the checkpoint of Lao, Cambodia country. What we do at our Cambodian side, all patient that people that cross by border, even go in and go out, we set a checkpoint to screen everybody. Luckily, we have been screened on time, and but we also not sure that whether the genetic epidemiology has been crossed the border or not, because we just only screen the fevers the patient and treat malaria. During that time, we don't have the data from the genetic epidemiology or CLEP 13 to be just map out in the country, even in Vietnam. But for me, near elimination also is important by each side of the country should have one common platform or data to view the resistance status of mutation, whether we can inform each country easily, and our country can read and do explanation what is going to be happen. So this is very important. One of the country cannot eliminate while the other country is still have a problem. Especially in Cambodia, quite a big challenge, because we have a mandate to eliminate malaria by 25, while our neighbor country like Vietnam and Laos still 2030. So there is a quite challenge for Cambodia. Need to have the map to view the resistance status of the strain, whether they has been pop up or has been come to cross border and something. So this is very important to us. Thank you.
Thank you. Thank you. That was a very valuable viewpoint. If I could just give a sort of very brief opinion here, I think there is such a strong connection and such a lot of people movement between the GMS countries that I think you're right. It has to be a common goal to do the elimination. And the truth is that importation can go either way. It mostly will depend on how strong the pressures of interventions are in each country. So I think if we are able to describe things across the different countries, across borders, we will do a better job. And I have to praise all of you for actually being very open with data sharing. It's been a very, very important aspect of the work we've been doing. Just before I call a break, any more comments from Dr. Quang or Dr. Keo?
No more comment. Thank you.
Okay, thank you.
No comment.
Okay, great. So with this, I'll hand you back to Arjen. I think we are going to have a physiological break now for 5 minutes or so.
Okay, we'll come back to our scientific forum. And now we are going to the session 2. This is about the multidrug-resistant malaria in Cambodia and its expansion in the Greater Mekong Subregion. And in this session, there will be 3 speakers. First, we'll start from Dr. Siv from CNM, Phnom Penh, Cambodia. And second will be Dr. Roberto Amato from Wellcome Sanger Institute. And the last, I will wrap up with the information from the GenRe-Mekong project. Okay, first I would like to introduce Dr. Siv. So he is a malaria program manager from CNM, Phnom Penh, Cambodia, and he will give a talk on malaria epidemiology and antimalarial drug resistance in Cambodia. Okay, Dr. Siv, please. Could you please unmute yourself?
Sorry. Thank you for everybody. I am Dr. Siv from the National Malaria Control Programme. I would like to present you the malaria epidemiology in brief in Cambodia and the history of the anti-drug resistant in Cambodia. Yes, you see from 2000, malaria case has been dropped out from more than 100,000 to only 4,000 right now in 2021. So this is a big success of the program that has been bring cases to the lowest cases in the country, and we don't have a malaria death since 2018, and now it's 4 years no one death due to malaria since 18. This is a big success of the control program, and we have a mandate to eliminate malaria by 25, and hopefully 0 PF and MIG by 2023. This is the map of malaria epidemiology in Cambodia. You can see the right side is a PF in MIG. You see in Cambodia right now, all districts have PF incident less than 1 per 1,000 population. It means that all the districts in Cambodia reach the pre-elimination status of PF malaria in the whole country. Except for PV and other species, we can see that they still have 9 districts still have the malaria incidence more than 1 and in the country. So but however, you can say that 91 of the districts of Cambodia have annual parasite incident less than 1, and except the 9 OD represent of 9% of the total of district in Cambodia will still have malaria incident more than 1. Talking about the history of drug policy change in Cambodia, you see since 2000 and from now, Cambodia used to known as epicenter of drug resistance, especially the Artemisinin-resistance and also multidrug-resistant in Cambodia. And you can see the diagram here from 2000 to 2010. We use a loose tablet of artemisinin, and from 2010 to 14 we changed to DHA-PPQ, and from 14 to 16 we use both DHA-PPQ and artemisinin, but from 16 and until now we use artemisinin as a whole country. But along the way here, we are not exactly the resistance is not emerged in whole country, mostly start from the western part of the country. So that's why you can see that from 2000 to 2010, it's there is a emerge of Artemisinin-resistant, and we also artemisinin-mefloquine or artemisinin-lumefantrate have also failure in some area, especially in the western of Cambodia. And so in that middle of the period 2008, we have been started use DHA-PPQ in Thailand, but however, just only 1 year use the resistance with the DHA-PPQ has been found, start to be found in Thailand. So even that in the whole country is not during that time that difficulty to say that we are used the same drug of whole country. In our country, we have used 2 different drugs because of some western part mostly start emerge resistant fastly than the other part of the country. So that's why in Cambodia during that time we has been used DHA-PPQ, we has been used Pyramak, and we also have used Atowacon Proganil in particular one place in Thailand. But now start from 2016, we has been use artemisinin-mefloquine because of artemisinin-mefloquine has been susceptible back after the nearly 10-year resistance from 2000. But until now, we don't have any problem with the drug resistance after we use artemisinin-mefloquine. There is some publication just told you that from 11 to 16 there is evidence of the DHA-PPQ has been failure in Cambodia, and from 16 to 17 we are, as I told you, when we are start to use artemisinin-mefloquine from 2016, but not whole country has been used the same time because of the resistance is not formally the same in the whole country. Mostly the western part is a problem, big problem, and the other part of the country is not so problem. And the other thing is drug delivery is not coming to the countries the same time. So that's why we have choose nearly 1 year to split the drug before we can use SMQ as a whole country. So it means that we has been replaced drug by western part, and after that we replace drug in the middle part, and after that and whole country because the availability of drug in the country. Speaking of the drug resistance from before, I don't want to explain more because this will be our colleague will be explain more about what is the multi-drug resistance in Cambodia, as everybody knows so far. Just to give you the update of the outcome of our TS studies in 2019 of PF malaria. You see, we 2019 we have 5 sentinel site whole country, and including the western part and also the eastern part of the country, and we has been tested with artemisinin-mefloquine. So you can see that there is all of sentinel site, the RCPL mostly 100% except one province near Thai border. There is 2 has been failure has been noted, and the efficacy only 88%. So but there is nobody know why the two patient is not susceptible with the artemisinin-mefloquine. But however, the sample size in that study is not high enough. So we cannot make any conclusion on that. So we are continue to do in 2020 with the same area, but unluckily we cannot find any the sample in the same area, so we cannot test for TS in that area, except the others 4 provinces still show the 100% RCPR of artesunate made protein, and the same time we also tested with artesunate pyroranidine, and also the food efficacy has been shown here. For vivac, we also test for vivac as well, and we see that the TA had been shown in 2020 that artesunate made protein and artesunate pyroranidine still work even with the PV in Cambodia. The country has been started at the beginning to use ACT to treat the PF and PV the whole country. But this just information to make sure that if we use the artesunate pyroranidine for vivac also work. And also last year also we test for artesunate pyroranidine with the P-falciparum, also that still can work. Currently, Cambodia, even we use artesunate made protein in the whole country, but we has been used artesunate pyroranidine for children less than five, because the currently not artesunate made protein pediatric dose available. There's only pyroranidine pediatric dose available. So in our country currently we use 2 type of regimen, the pediatric dose artesunate pyramid, and the children and adult dose we use artesunate made protein. We don't want to use 2 type of drug in the country. But there is no available artesunate made protein pediatric dose in the market. We has been ordered Cipla 2 times, and they try to produce for us, but the problem is the quality test has been failed 2 times. So we have no choice to use a pyramid in the country right now. We also choose artesunate the pyroranidine pyramid as a second-line treatment as well. In our new treatment guideline, if SMQ has been failure, instead of use quinine and tetracycline, we can allow to use a pyramid for the second-line treatment as well. I think that my presentation is not long enough, so I think thank you for everybody here. Thank you.
Well, I think your presentation was very thorough and very interesting, actually. So thank you very much, Dr. Siv. And again, we'll keep questions for later on. Right now, what I would like to do is to introduce Dr. Roberto Amato, who's a scientist who's the lead of the analysis group at the Wellcome Sanger Institute in the UK, and he was leading a number of research studies on the genetic markers of piperoquine resistance, which we conducted largely in collaboration with studies in Cambodia as well as other neighboring countries. So Roberto, would you like to take over?
Thank you. Can you see my screen and can you hear me? Can you see me?
Yes.
The usual.
Yeah.
Great. Okay. Thanks, Professor Olivo. Thanks for the introduction. It's really a pleasure to be here. I'm realizing what I'm going to present today is very complementary to what we heard so far. We heard the view from our perspective, from the human perspective, what's happening in the field, the number of cases, number of deaths, and great to hear the numbers are going down. What I'm going to present is kind of complementary to that. We're going to see from the parasite point of view, as in from the parasite genomic perspective, molecular perspective, what was happening during those the past 10 years or so. By the way, welcome to my bedroom. I realize I should have picked a better background than that. So because I'm going to cover a different aspect, I thought I'll start from the, from first principles, really. I'm going to start from the basis. I don't think Kelch needs an introduction as such, but just in case, Kelch13 is a gene in the parasite genome that causes resistance to artemisinin. We actually know that it's a causal relationship. It's not just an association. This paper came out in 2013 from the Institut Pasteur. And shortly after, if my memory is correct, which never is, no more than a couple of months later, a few months later, this clinical study led by Liz Ashley and MORU, I'm showing a figure from the paper here, confirmed that in the field. And two observations came out of that study. First, wasn't just a mutation in Kelch13. So we're kind of going away from this idea of, CRT, for example, where K76 or 76T cause resistance to artemisinin. The picture seems to be a bit more complex. So that was difference number one. Different number two was that at the time, sort of surprising, or maybe not, this mutation seems to be arising independently, as in we're not really looking at the spread of this mutation. The spread from a molecular perspective wasn't really spreading, but was emerging in large part of Southeast Asia, in particular around the Greater Mekong Subregion. Again, this figure, I think you're familiar with that, but just to cover the bases, as I was saying, shows the parasite clearance half-life that's measured in the patient, in the clinical study led by Liz. Numbers above 5 hours that indicate parasites that are resistant to what we call resistance to artemisinin. Below 5 hours are parasites that are sensitive to artemisinin. One reason for putting this figure up is to remind ourselves that even if we do know that this is a causal relationship, as in you can edit the genome of the parasite, introduce this mutation, and you will observe the phenotype, this is never clear-cut. Look at this parasite here, for example, despite having no mutations, no Kelch mutations, still have long half-life, as well as this one. This is our well-known 580Y. With short half-life. I'm not saying anything new there, but just keep in mind that genetic molecular markers are great proxies, but never shouldn't be taken as the absolute truth. So that covers Kelch and artemisinin-resistance. The other part of the story is around piperacin, plasmepsin and piperacin resistance. In 2017, we published this study, again, another clinical study, where we observed that this amplification of two genes in the parasite genome, called plasmepsin-2 and plasmepsin-3, they sit next to each other on one of the parasite chromosomes. When you have tandem duplication, that is, instead of having one copy of each gene, you have multiple copies, 2 or more of those genes. Not only you observe a piperacin IC50 going up, that is in vitro, measured in vitro and ex vivo, essentially is how much drug you need to kill the parasite. So this number is going up. This on the left are parasites with a single copy of those genes, on the right are parasites with multiple copies of the genes, and as you can see, the phenotype goes up. But more importantly, parasite with multiple copies of the genome seems to be causing complete treatment failure, as in the chance of the patient getting well after being given artemisinin piperacin, which was the frontline treatment at the time, as we just heard from Dr. Siv. goes down by more than 6%, in fact. So it's almost a 50-50 chance, even worse than 50-50 chance, whether you'll be cured with DHA-PPQ if you're unlucky to carry a parasite that's got both Calc13 mutation and plasmapsin amplification. I don't think I've said anything new, but I think that was important to introduce this plot, which is analogous to other plots we've seen during the day since this morning. So this is the frequency of artemisinin and piperacin resistance in Western Cambodia between 2007 and 2013. As I was saying, but this is looking from the molecular perspective, as in looking at the parasite genome and see what the frequency of this mutation, again, Calc13 mutation for resistance to artemisinin and plasmapsin 2 and 3 amplification for resistance to piperacin looked like over the year. And again, it's now more than 10 years, but we do know the picture. Artemisinin was already fairly high prevalence at the time in the region. Piperacin goes up quite rapidly and pick up to reach pretty much took the almost complete prevalence in the region. This is an important picture because, as I was saying, gives you a snapshot in time of what is happening. Although we do know that there are other ways to get the same picture. For example, we've heard. Sorry, I'm coming down with a cold, so apologies if I'm coughing. There are other ways to get to similar conclusion, probably even more accurate, you might argue, by therapeutic efficacy studies, clinical studies in the region, and so on. So far, nothing new. But what this kind of analysis led us to do was actually looking under the hood. Let's open this parasite quite literally, in fact, and let's see what this increase in frequency really looks like. What is going on? Is it still the case of, as I was saying at the very beginning, in the very first slide, of these mutations coming up independently in different parts of, in this case, of the country, later on in the Greater Mekong Subregion, or there is something different there? To do that, we use what is called statistical chromosome painting. I'm not going to go in details of what that really means, but the bottom line is we're trying to analyze haplotypes, that is the part of the genome in and around the Calc13 locus, and later on also in and around the plasmapsin locus. And we assign each sample to what we call genetic type of resistance. What I mean by that is a group of samples that has the same resistance mutation, strong haplotypic similarities, that means the genome in that part around Calc looks pretty much the same. And when you take these two things together, that means that there's probably a recent shared use the word lineage at the locus, as in there is relatedness between these parasites, at least as measured locally. To a first approximation, although it's not completely correct, you can imagine genetic types as different molecular origins or resistance. Now, remember that Plasmodium is a sexually recombining organism, so the analogy with COVID doesn't quite hold, but you could almost imagine these these epidemiological lineages like the ones we see in COVID, like imagine those as, I don't know, the Delta and Omicron and so on, BA1, BA2, and so on and so forth. Again, don't read too much into the analogy. It biologically just doesn't work, but it is a good concept to keep in the back of your mind. So in total, we identified more than 30 types of artemisinin resistance and at least 3 different types of piperacin resistance. So in the figure on the left, I'm showing the haplotypes that surround the Calc13 locus. Calc13 is here in the middle. And this is in about, if I remember, 500 Western Cambodian samples, which are represented on the row, as in each row is a different sample. In orange and in pink, I've highlighted the samples that belong to the 2 most common types of artemisinin resistance. The most by far the most common one being what we end up calling Cal1, which are this parasite here, which, as you can see, they're very similar from a genetic standpoint. You could already see in the previous slide, but let me stress even more and take this point home. Not all types were created equal. Some were more common than others. One of these types, which again is a specific origin of KEL13 mutation, which we call KEL1, and in fact a specific origin of plasmapherin amplification, PLA1, rapidly became dominant and was the main lineage responsible for treatment failure in Western Cambodia during those years. So this plot on the left tries to unpack these dynamics in a bit more details. The thick black line is the same I was showing a few slides ago and depicts the overall trend of Artemisinin-resistance. Of course, in Western Cambodia between 2007 and 2012. You can distinguish two distinct waves underneath the line. The first one, when the KEL1 type in yellow became dominant. You can see it starts as a fairly lame type at the beginning. There's much more going on, but then rapidly picked up and becomes pretty much the dominant lineage. The second wave, which is here in yellow and red lines, and yellow and red dashed lines, is when there's two types. The specific origin of Artemisinin-resistance, talking about KEL1, and the specific origin of pparaquine-resistance, which I'm calling PLA1, come together and essentially wipe out completely the competition. Again, loose analogy with COVID, you can see KEL1, PLA1 as, for example, Delta, which took over, at least in UK, the COVID population before Omicron came around. But that's Western Cambodia. What about the rest of the region? Unfortunately, the spread of this type of resistant didn't really stop to Western Cambodia, but spread across the national borders into neighboring countries. And in some cases, and I'm showing the frequency of again, this KEL1, PLA1 type in 6 regions in the in 6 areas of Greater Mekong Subregion. You can see in some places like Northeast Thailand or North Cambodia, actually KEL1, PLA1 reached the frequency nearly 100%. That means KEL1, PLA1 had completely overtaken the local population, completely wiped out the local population. The reason why one of the reasons why I'm talking about KEL1, PLA1 here is to, again, credit to GenRe-Mekong project. Once you've done all the work in identifying these types, again, think about COVID. Once you've done the work in identifying what Omicron really means, now you can actually roll it out and being part of routine surveillance. For example, even with Amplicon, which is what Olivo and colleagues have been doing for a while. That means, again, that allows to have high resolution picture like the one I'm showing here, or the one even higher resolution that Olivo was showing at the very beginning of this forum. Now I'm talking about KEL1, PLA1 spreading. But I haven't really quantified that statement. So is it really like that? So if you take KEL1, PLA1 parasites from across the region, no matter where they are from, they all look more similar to each other than non-KEL1, PLA1 parasite. That is, you take KEL1, PLA1 from Vietnam and you take one from Laos, those KEL1, PLA1 parasite actually looks, you can still see at a genomic level, they're very, very similar to each other. They're very close genetically, much more than you will for example, if you were to take a KEL1, PLA1 parasite from, let's say, Laos or Vietnam, and compare it to another parasite, which is not KEL1, PLA1 from Laos or Vietnam. So basically, KEL1, PLA1 form one sort of family. I'll show in a second that this analogy doesn't quite work. There is more differentiation than that. But still, you can see this family of parasite being related and spreading in the region. Even a few years later, you can still see sort of ancestral signature of the original spread. I've used the analogy with COVID a few times now, which I think makes for good way to contextualize results. But I've also tried this is really not accurate. This is particularly evident when you look at genetic similarity within the KEL1 PLA1 group. As I was saying, regardless of the region, they are related. But actually, when you look within that group, when you look now genetically within the KEL1 PLA1 parasite, you start distinguishing what we call subgroups. You can almost imagine as in subfamilies, or I don't know what the correct terms is. Keep in mind, these are recombining organisms. So just want to stress out, this is not a pedigree. This is not a family tree. This is just a visualization and nothing more than that. What I want to point your attention to is this group of parasites, which are incredibly similar from a genetic standpoint, hardly have any difference. In fact, when you look at the entire genome, they are all clones of each other. I'm not making any claim of how they are related to each other across subgroups, but within each subgroups, you can see there is almost complete identity. What was particularly worrying is that each one of these subfamilies seems to carry additional mutation elsewhere in the genome, in particular in CRT. And independent clinical study led by Rob van der Pluim at MORU at the time shows that those mutation, those CRT mutation, again, survival curves on the right, do have a more negative outcome than parasites that don't carry those alleles. So the picture starts to get a bit more complex. And speaking of complex picture, I'm going to show an incredibly complex one, so please bear with me. You can imagine that the reason why this slide is half empty is because it's going to get incredibly busy in a few seconds. I'm going to take you step by step. I'm going to take one bit at a time. So what I'm going to show on the left is the CRT gene. As I was saying as I was saying a few seconds ago, mutation in this gene seems to, in addition of KEL1 PLA1 lineage, seems to give an even more negative treatment outcome. Gray dots are mutation actually happen to be a background, the CRT genetic background, which we know very well is actually the same genetic makeup for this CRT gene that we find in the parasite called DD2. This is a known lab strain. It's got a certain number of CRT mutation, in particular 7060, we know as chloroquine resistance, plus something else. Then I'm showing in the middle the proportion of samples in 4 different populations from Asian populations that carry the haplotype, and finally the number of samples in the new data release is coming out in a few weeks, 20,000 parasite samples from all around the world. Again, in that release, this is the number of parasites that carry the specific haplotype. Now, hold your breath. This gets very busy, but don't be scared. You can see that the first haplotype I was showing, the DD2 CRT haplotype, is by far the most common. Please note this is a log scale. So there are dozens of parasites in the PF7 release that carry that haplotype. But right after that, there is a number of haplotypes, and let's focus on, just for the sake of argument, on the first 4 or 5 here, which carry additional mutation on top of that background. So this is, if we look at the second row here, this is a KEL1 PLA1 parasite, which has got a DD2 haplotype in CRT, plus an additional mutation, in this case, T93S. Again, one of the mutations identified by Rob in the clinical study. The good news, if there is such a thing, is that if you look at the prevalence, geographic prevalence of this parasite that carry this very complex genetic architecture, seems to be constrained to what we call east part of Southeast Asia, that is Cambodia, Vietnam, Laos, and eastern part of Thailand. So that's good news. And by the way, all credit to Richard Pearson, Anastasia Hernandez-Koduchev, and Jacob Almagro Garcia for this analysis. I'm running out of time. I just want to leave you with one final finding, which I'm going to put in the category of good news, assuming there is such a thing. We were already seeing that switching to artemisinin mefloquine at some point was beneficial, as in was working. I want to supplement that with additional finding. This one again is in vitro, and this is to stress again why we care about KEL1 PLA1. Well, one reason I've already said, we can track those KEL1 PLA1 parasites. We know they're DHA-PPQ resistance, and they give us a good handle, a good hook to see how they're moving across the region. But the other reason is that as it turns out, they might actually have, and I'm using the conditional here, some genetic makeup that make them more sensitive to, for example, mefloquine, as I'm showing here. So we know that MDR1 copy numbers are associated with mefloquine resistance. That is, parasite with a single copy have a low mefloquine IC50. Parasites with multiple copies of the gene MDR1 are resistant to, or what canonically is considered resistance to mefloquine. But look at the KEL1 PLA1 parasites. They are so low on this plot. Means not only they're sensitive to mefloquine, but to use an analogy from Olivo, actually, you don't even need to use mefloquine. You can just show the package of the drug, and those parasites go. So again, these are unpublished results. We hope to wrap it up. And in reality, what's really important is what is happening in the field and whether these drugs are working or not. But again, taken together, that shows why this nomenclature kind of works, why it's useful from a surveillance point of view. Just want to leave you with take-home messages. I think it's very, very clear from everything we heard so far that the emergence of antimalarial drug resistance is a matter of when and not if. That means we need to be prepared. And timely intervention are critical. By the time we've done all the clinical studies and so on, actually, KEL1 PLA1 had already spread in a number of countries. So, and this connects to what we're going to hear later in the day and tomorrow. We need ways to decipher the trajectory at the very early phases of resistance, as in as soon as possible, so that we can stay ahead of the game. And again, we're going to hear some great stories about the characterization of the outbreak in Lao. Just want to finish by thanking an insane amount of people that have been somehow responsible for this work in one way or another. I'm not even going to try and name anyone. Big thank you, but a special mention to the GenRe-Mekong project, as in really this collaboration with control programs has been by far the main reason why I've been able to look in details at the dynamics of spread of resistance in the region. And thank you all for listening.
Okay, well, thank you very much for that wonderful presentation. It was quite a ride, I'd say. And I had forgotten I said that thing about the packages, but never mind. Now, actually, there's as a way of introducing the next talk, I would say, you know, a lot of the interesting results that Roberto showed in this presentation were obtained using whole genome sequences. So, you know, very, very detailed sequencing information from the whole of the genome of the parasites. Now, whole genome sequencing is in a way, the best way of getting the most information out of each sample, but it is difficult to handle in terms of the amount of data that is provided, difficult to analyze, and relatively expensive. So in GenRe, we do contribute the samples. We do whole genome sequencing of the samples, which takes takes more time and is eventually becomes available for this type of analysis. But in the meantime, we actually take a sort of condensed version of the genomic information that we call genetic barcodes. And these have been mentioned a couple of times today. And Arjen here is going to give you a somewhat more in-depth look at what are genetic barcodes and how do we use them and what are they good for. So Arjen, it's up to you. Yeah.
Okay, thank you very much, Professor Oro, for the introduction. And as Professor Oro says, I will introduce about the genetic barcoding that we use in our DAY1 project. That is like a simplified version of whole genome that we use to do the epidemiological analysis of multidrug-resistant malaria. So first, okay, I will give the overview of the genetic barcodes and how do we do the data processing and analysis the genetic barcode that we providing in our project that we get from the genetic information from dry passport sample and go to the data processing and analysis and give result back to the National Control Program. So first, this figure show the how can we know and how can we get the information about the genetic barcode. For the Plasmodium falciparum, the parasite have the 23 megabase nuclear genome, which have the 14th chromosome, which quite a little bit big. If you would like to do the whole genome sequencing, it will take time. So in our project, we just get the like a simplified version of the whole genome with the 100 high diversity SNP across the genome. This SNP is not associated with the drug resistance, but it will give the overview or the get the main information of the parasite that we can use for estimate the complexity of infection and can use for the analysis of genetic relatedness and diversity of the parasite. And also we can use it to identify expanding strain and the geographic origins of the samples. So, so by using the genetic barcode, first we have to get the genetic information from the sample. So this is an overview how we get the genetic information from the dry passport. From the field by the GenRe-Mekong partner, by the National Control Program or our scientific partner, they will got the dry passport on the filter paper and then make the DNA extraction. And using the selective whole genome amplification primer that designed by the Malaria Gen and Support Malaria platform, we will get the in the primers, we will get the information from the 100 SNP genetic barcode and also including the genetic variation that relevant to antimalarial drug resistance and for the species identification. So after the selective whole genome amplification, we in our project, we did the genotyping and sequencing. For the first version, we use the multiplex mass spectrometry arrays or Agena mass array for the most SNP, and just only for the KEL13 gene, we use capillary sequencing. And the second version now, we currently use the amplicon sequencing using the Illumina MySeq sequencing platform, as Dr. Nguyen had introduced to you that we also have in the Sanger, and also now we establish lab in Vietnam in Oc. After we get the genotyping and sequencing result, we make some data analysis and process the data and get back to the our partner by in the form of genetic report card. So I would like you to go through the genetic report card that we provided back to our partner. It is a simplified form with the tabular form format with the Excel spreadsheet. that including information of the sample metadata and also sample selection criteria for analysis. That is the part of the sample information. And another field, we will include the genotype information, with including the key drug-resistant genotype and haplotypes, and also parasite genetic data species that used to determine the complexity of infection. And another field, we have the prediction of drug resistance that will give overview of the parasite and for use to determine the prevalence of drug resistance in each area. And another remaining two fields, we give the detailed genotype at each loci that relevant to drug resistance and also for genetic barcode that is used for data analysis later. So in this slide, you can see the logo that is the form of the data spreadsheet, yes, that we provide back to our partner. And for to facilitate the data analysis, in our project, we have developed the DRC Malaria package, which is an open source tool for processing and analyzing spot malaria genetic report card. So from the Excel, as you can see on the left-hand side, that we provide back to our partner, by processing using the DRC Malaria package, we can get the graphic form of maps, graphs, or tree that will be used for communicate with healthcare teams and National Malaria Control Programs. So this is the information that DRC Malaria package can provide. Yes. After data analysis, you will get the general information, just like frequency measures of the drug resistant. I mean, in terms of the predicted phenotype and also mutation. Additional, you will get the genetic diversity of parasite in each geographical area. And also we can see the genetic connectedness and cluster analysis of the parasite that I will show you later, that we can see the map and tracing the movement of the parasite. And for deep analysis, you can also see the population structure analysis of the parasite from each region and even cross-border or in the sub-region. So now I will go through the genetic barcoding that we use for epidemiology analysis of multidrug-resistant malaria. We will use the example that we analyze the data first from the Cambodia and to see how the spreading of multidrug-resistant strains spread in the Greater Mekong Subregion. And I will bring you through how can we apply the genetic report card that to see the drug-resistant prevalence and also genetic of drug-resistant parasite in Cambodia, and using the genetic barcode to track the multi-drug-resistant malaria in this region in GMS country. So first, as Dr. Siv says and showed you before, this is some of the background of the drug-resistant malaria that emerged in the GMS, along with the change of the drug policy in Cambodia. You will see that firstly, there are the evidence of Artemisinin-resistance that in 2008, and so Cambodia adopted the DHA-PPQ. After that, after a long way to use the DHA-PPQ, so in 2013, there are the emergence of DHA-PPQ resistance. And at that time, we have the information about the molecular marker for Artemisinin-resistant and also PPQ resistance. So we can know what happened, and there are some. After that, using the genetic marker to determine the resistance, we can see the spreading of the DHA-PPQ resistance in the genes. So based on this information, when using the genotyping data, so we can have the molecular marker that can predict various kind of drug resistant against the key anti-malaria drugs, including artemisinin, piperaquine, pyrimethamine, sulfadoxines, and so on. And based on this mutation that we predicted from genotyping, we can use is to determine whether the parasite sensitive, resistant, or undetermined for the status of drug resistant. So this one is similar to the one that Dr. Roberto have presented, that there are the quite sharp increase in the K1 PRA1 strain during 2010 to 2013, yes, in Cambodia. And after that, there are the study from Professor Malaria Quang that show there are the spreading of the K1 PRA1 across the region from the Cambodia, in the West Cambodia to East Cambodia, and also in the Southern Laos and West Vietnam. So from this one, now we have the information that we collect under our project from the GenRe-Mekong by the clinical trial and also by the genetic surveillance. There are total number about over 3,000 samples that have the valid data on the genotyping that we use from the even from mass spectral array or empirical sequencing and whole genome sequencing. And we did analysis for based on the time of the drug policy change in the Cambodia, just like in the first phase of the artemisinin-resistant and then change to DHA-PPQ. And there are the transition phase in 2014 to 2017. There are the change in the drug used in Cambodia, and now in Cambodia they use artemisinin-resistant. From this one, we got the genotyping data and translate into genetic report card. And using the GRC Malaria package to determine the drug resistant prevalence, frequency of polymorphism in KEL13 gene, and additional to see whether how the spreading of the parasite. So we determine the genetic connectedness and clustering analysis of MDR parasite in this area. And the last, we determine the emergent, expansion of multidrug-resistant parasite in Cambodia and also in GMS country. So this is the brief information about the prevalence of resistance to key anti-malaria drugs. As you can see in the first phase of artemisinin-resistant, we see the high prevalence of resistance to artemisinin, okay, while there are the low prevalence of piperaquine or DHA-PPQ combination. However, after the change of drug policy to use DHA-PPQ as a first-line drug, there are the sharp increase of resistance to piperaquine and DHA-PPQ, as you can see in the dot line in the blue and in purple line. Yeah, this one, and it's continue high until 2019. And with this one, if you see the below graph in the pie chart, you can see that the major mutation that involved in the artemisinin-resistant is still in the C580Y, as you can see in the red big area of red color. Yeah. And its expansion along with the time. So from this one, we try to see whether there are any difference between the strain that have the KEL13 that have mutation in C580Y. So on the right-hand side, you can see the bar chart that we make the analysis, and we can see the red one is the parasite that have just already mono-resistant or mono mutation of the KEL13 at the 580Y, where the purple color show the one that have the that is KEL1 PRA1 parasite, and you can see that there are the expansion of this multi-drug-resistant parasite along the way. So Now we try to see whether there are any different of the strain in the K1 parasite by using the genetic barcodes. And now I would like to show you a little bit about the idea how can we use the genetic barcode to estimate the genetic connectedness. This figure shows the brief idea that just like this one, we have the 101 SNP that concatenate together in the sample number 1 and sample number 2. You can compare that each position. If there are the different, you can see the red color. So with the high mismatch in the SNP, you will have the high diversity. And if you have the sample number 2 and number 3 with low number of mismatch, we can estimate that there are the low diversity. So from this one, we can use to identify or determine the connectedness, diversity, and population structure, and also transmission routes of the parasite. So the way to understand are there any the transmission, or is the normal transmission or random netting, or even is transmitted by the selected parasite? We can see the change in the population diversity. On the left-hand side, you will see that it is the normal transmission or high diversity of parasite, because parasite has random mating, so it have their own or unique type. The pale gray area show the one that have unique, and the one that's shading with the brown yellow color, that means they are the grouping into the same genotype. While on the right-hand side, you will see that there are the big chunk of the shade one, the shade that yellow color, okay, with the big one, and just a small area of the gray color. That means there are many parasites that come together in the same group. As you can see, it is the low diversity. And when we go to the population of the parasite in Cambodia, compare from the wild type and the parasite with the mutation as C580Y, and also the one that have the K1 power. You can see from the above line, we see the one at the 100% level of similarity. The second one is 90% similarity, and the last one is 80% similarity. You can see for the white type, you will see that there are the usual like the situation of the parasite that are random mating. So you will see the large area of the gray color that have the unique. While the drug-resistant strain with the 3,5-Y, you will see the increase of the group of parasite. Okay, and when we combine for the parasite with the C580Y and K1 you can see clearly at the genotype or genetic similarity at 80%. There are the big area of group of K1 together. So that means that this indicated the transmission of the selected by the drug resistant, the selection of drug resistant. Okay, so we'll go into to see how the distribution or how it's spread across the border. And you can see there are the major group of the K1 as Dr. Roberto presented are the subgroup. And by using the genetic barcode and analyzing with the GRC malaria package, we can see the connection of the parasite in the different way. So just like you can see the 4 major group here, as I show in this figure, group A, group B, group C, and group D. All of them is identified as a K1 parasite, but there are the distribution in the different time frame. Just like in the group A and group B, they are distributed in between year 2013 to 2019. While in the group C and group D is the one that is, these two parasites have longer distribution, yes, from the 2010 to 2018. And for the group D is the one that persistent in, I think, is the first happened in the Cambodia and then spread into the southern Laos in 2008 to 2021 at the present time. Yeah. And also with this genetic barcode, we can identify the special strain that have emerged in Vietnam that is separately. Yes, that is the different strain from the strain that originate in Cambodia. And by using genetic barcode, we can construct the tree and we can see the expansion of the K1 PRA1 parasite in the Cambodia-Laos border. From this figure, this is the neighboring joining hood, the joining tree. So you can see there are the parasites in the group that show in the pink and blue color, that is in Sawanakhet and Salawan, that is the upper zone of the southern Laos. While the parasite in Atru, as you can see in the orange and in the red color for the Champasat, that is the lower side of the southern Laos, which is in the border of the Cambodia and Laos. You can see in the part that have A, okay, in the part A, you will see the K1 PRA1 is concentrate or intense, have high intense is the lower zone. So using the genetic barcode, we can identify and can know where the parasites come from. So now we go to the summary. So for the overall, we demonstrate the usefulness of combining the standardized drug-resistant markers and will establish the 100 SNP barcodes, which allow us to determine the genetic epidemiology studies of multiple data sets for the large scale and long-term surveillance of malaria parasites. So finally, I would like to thank all to the National Malaria Control Programs in the GMS country and also Oxford University and Sanger Institute and also our supported grant. Thank you very much for your attention.
Thank you, Dr. Arya. So, I mean, the take-home message there is clearly what we are genotyping with the amplicon sequencing right now is not as detailed and sophisticated as the whole genome data that Roberto showed us the applications of, but it already allows us, for example, to split between different groups of KEL1, PLA1, just as Roberto has shown. So it does provide some sort of important level of sensitivity when we do this analysis of the data. And what we are hoping over the next period is to develop more methods and more visualization of this data, and also so tying back to what Dr. Siv was asking earlier on, we will also sort of ensure that we train people adequately to understand these results and to be able to produce their own, in fact. So now we're coming to a close, but I would like to handle any questions here that have been asked. So I got one from. Oh, sorry. Sorry, you check. Actually, first of all, could I ask a question about to Dr. Siv, in fact, about the options for Cambodia? Had you considered another idea that's been discussed quite a lot recently? Has been using triple artemisinin combination therapies. You know, using 2 partner drugs for artemisinin instead of 1. Did CNM consider that in Cambodia, and what was the thinking?
Yeah, thank you very much, Dr. Olivo. Currently, while the SMQ has been the full efficacy of a drug has been treatment in Cambodia, so the considering of a triple therapy still hang on. It means that we are not consider on that yet. But however, we are going to put this in the new treatment guideline as an option, whether the resistance has been happened, and we can have a choice to use that. The big problem of Cambodia right now, we launching the new approach of the last mile elimination by WHO strategy. There is including the TDA and also the chemoprophylaxis to the general population. So SMQ is a big concern of side effect when we apply to the general population, and now we also concerned that if we are talking about the triple therapy, and in terms of using the new strategy, TDA or others, IPTF, seem to be that whether there are big problem or the side effect will occur. Even the study has been shown that the side effect is not really high. It is similar to the not the triple. It's not different from the current ACT. But even that, but people still not happy with the current ACT that we are provide for the TDA or chemoprophylaxis to the general population. So that's why we are hesitate to thinking that whether we are talking about multi-drug combination therapy. But however, we has been agree to join with the MORU team to access the acceptability study of marketing in terms of triple therapy, in that we has been proved that the efficacy is already there in Cambodia, and also can be avoid the resistance in Cambodia in the future. So hopefully that's we are, however, we also put an option on that. Thank you.
Great, thank you very much. And just to be clear for those who are not involved in this, TDA is targeted drug administration, correct?
Yes.
Okay, so basically giving the drug as prophylaxis to a large number of people. So
just one more question to the speaker, that we are talking about the CAL1 and PLEF1, that is so the high sensitivity compared to the looking for the prediction of resistance. So what is the level of sensitivity we are talking about? And I don't know that you're talking about high sensitivity. So what does mean high sensitivity compared to the one that we already do by only see the C580? Thank you.
Sorry, which speaker were you referring to?
I can take that, Oliver, if you want.
Oh, sorry. Yes, Roberto.
So we only have molecular data for that, and I mean, credit good to Parat Lim and Chanaki Amaratunga for collecting this data. In lab, these are ex vivo IC50 experiment. We see that you need about half of what half we see about half of the IC50 that we'll see for normal sensitive parasite. That is, on average, you need 20 nanomolar, if I remember correctly, for sensitive mefloquine sensitive parasites. KEL1, PLA1 seems to require even less than that, in the order of 10 or so. But again, I want to stress these are in vitro study. What that translates to in terms of clinical practice, what that translates to in terms of public health, that's a big open question.
Yeah, thank you.
Sorry, by the way, I made a mistake and throughout Richard's question here. Richard Pearson is asking, in a recent talk, I heard that since the failure of DHA-PPQ, artemisinin-resistance is being used in Cambodia. Dr. Siv, can you confirm this is not the case, right?
No, AL has been the use in the pilot study for the forest grower that has been done nearly 2 years by the Richard Group. They use AL for the forest grower for chemoprophylaxis. But seems to be that the result is good, quite good, and also the acceptability of people also quite high. So so this is the study that had been shown.
Okay, thank you very much. I have one last question that I would like to ask the speakers, which is our initial investigation in the last year or two shows very little, if any, presence of MDR1 amplification now in Cambodia, even though the country now has been using mefloquine again for quite a while. Can we do we think we know why this marker is not rising? I mean, it's good news, but do we have any ideas here?
You ask me or you ask who?
Well, why don't you have a go?
That for me, there is very proud that is SMQ still efficacy in the country, and also we thinking that this drug can be used only less than 5 years, but now it's more than 5 years. The efficacy still high with the artemisinin-resistant. I don't know the reason on that, but whether we have a few cases on that of PF, still a few cases. So the chance of resistance of parasite maybe cannot have a chance to develop faster because we have few cases. But this is my explanation. I don't know in genetic point of view. Thank you.
Roberto, do you have an opinion? Well, I always do, but doesn't mean it's a good opinion. Well, it's $1 million question, right? I mean, I can only think of other questions to ask on top of that. For example, are there other mechanisms of resistance that have been developed by the parasite? Is there any sort of antagonistic effect between copy number in different parts of the genome? For example, for as long as plasmepsin amplification are common in the region, are we expecting to see amplification in MDR1? We know anecdotally that's a very rare event. Is it possible that amplification in MDR1 don't get along too well with mutation in CRT? I'm just answering your question with more questions. It is intriguing. It's probably not what I would have expected naively, in particularly when you stop pressure on with piperazine, and we know how plastic the Plasmodium genome is, as in they can amplify, de-amplify genes quite rapidly. So it is interesting, and I wonder whether that gives us options for more sustainable intervention going forward.
Very good. Well, thank you very much. Now, I would like, I think this is sort of perfect timing. We are at 5 o'clock, and that's really all we got time for. What I would like to do at this point is to thank everybody, thank all the attendees for participating, and I hope we will see you tomorrow again at the same time. But especially, I would like to thank all the speakers for very, very good presentations. And could I get everybody to unmute and give them a round of applause? Thank you. So that is it for today, and we will rejoin at 2 o'clock Bangkok time tomorrow, same time. Thank you very much, and see you.
Thank you. See you.
Thank you very much. See you tomorrow.
Thank you.
Thank you very much.
Yeah, thank you.
Bye bye.